students, our study today is about cross product. Before we did the scalar product or the dot product. The scalar product, it was u dot v, it was a number, not a vector. However, what is a cross product? A cross product of two vectors. Suppose you have two vectors u, for example, and vector v. This is u and this is v. The cross product of vector u cross v is a vector perpendicular to the plane formed by these two vectors u and v. So how do you find it? So suppose you want to find u cross v graphically. So you put first of all you take the point of intersection of the two vectors. This is called right hand rule. You put your hand here, okay, and you put your hand on the vector u, the first vector given. For example, here the first vector given is u. You put your hand on the vector u, and you close your finger. If the vector v is towards inside of your finger, like this one, to the left of your finger, you can see that this is vector v. So the perpendicular will be upward. However, if you do vice versa, if I want here to find v cross u, so this is the intersection. If you put your hand here and you cross your finger towards inside, like I did up towards inside, this is your hand here, okay, you close it towards outside, you can see that the vector u is not towards the inside, it's towards outside, so the perpendicular will be down. Always u cross v is minus v cross u. So if it's upward, so if you do vice versa, it will be downward. So minus v cross u. Okay, so this is v and this is u. Graphically, what does this mean? As we said, it's the perpendicular on the two vectors u and v. And if I want to write it arithmetically, so it's norm of u times norm of v times sine angle of between. This is a distance. It's a distance of this vector, the measure, the magnitude, the norm of that vector. And to be a vector, so I multiply it by the unit vector of the perpendicular, which is n. So suppose this vector has unit vector n, so it will be times n. So it has the norm. In this case, it's written as the product of its length and direction. So if vectors are parallel, you know that if vectors are parallel or opposite sense, parallel and opposite sense, so the sign of 0 degree, if they are parallel, or opposite sense, if one upward, downward, and they are parallel, sign 0 or sign 180 is 0. In that case, u cross v is 0. So if two vectors are parallel, we cannot have a cross product. The cross product is 0. Here are some properties. If you multiply cross vectors by r and s each one, you can put it before. V cross u is minus u cross v. 0 times any cross vector u is 0. And here, if you have it this form, you can distribute u cross v plus u cross w. Here, you're going to get v cross u plus w cross u. Here, you're going to get, later on at the end, we're going to talk about that one. But what concerns us, that v cross u w is a vector, and product of two vectors u cross u prime, for example, is also a vector. So now let us continue. Graphically, what does it mean u cross v? U cross v, as we said, is norm u times norm v times sine of angle in between. Now, if you do sine theta is the height, here the height over the hypotenuse, okay? So sine theta is the height over the hypotenuse. So in that case, what will be the height? It will be, if you do sine theta, as we said, equal height over the hypotenuse, and the hypotenuse is norm of v. So in that case, sine theta times norm v is nothing else than the height. So you're going to get height times u. And height times u, this is the height and this is vector u, is nothing else. You all know this, the area of parallelogram. So what does u cross v, norm of u cross v, the measure of this vector perpendicular to the plane? You don't have u cross v, this is the vector perpendicular to the plane, we said. The distance here is nothing else than the area of the parallelogram formed by the vector u and v. If I'm going to talk about triangle, since triangle is half area of parallelogram, so u cross v, if I want to find the area of the triangle, it will be 1 over 2 u cross v. Okay, so u cross b, which is a vector perpendicular, if I want to find its distance, its measure, its norm, is nothing else than the area of parallelogram of formed by the two vectors u and v. Now I have a three-dimensional. This is the x-axis. The norm is I here. Here the y-axis, the norm, if the unit vector, sorry, is j, and this is the z-axis. The unit vector is k. So if I'm going to find, if I have these two vectors written in scalar component form, if I do cross of this vector, for example, here I cross I, because I is parallel to I, so 0. If you want to do I cross j, for example, this is I, sorry, this is I, okay, and this is j. So if you put your hand here, your thumb here, your right hand rule, j is to that side, so you're going to get vector k. If you do all this operation, you're going to get at the end that u cross v is nothing else a vector which is perpendicular to the plane formed by these two, and it's nothing else than the determinant of ijk, where you put u1, u2, u3, components of vector u and the components of vector v. So here the property u cross v is nothing else, as we said, is nothing else than the determinants of vector u and vector v. So let us go to the application problems to understand it. Here the question is to find u cross v and then to find v cross u. I gave you two vectors. I know that u cross v, if this is vector u and if this is vector v, u cross v is nothing else than the vector perpendicular to the plane formed by u and v. So this is u cross v. But if I want to find this vector v, the components of that vector, like here, so I do a determinant. I put ijk first of all. I put the components of vector u and then the components of vector v. So I start I into 1 minus 3, as you know, determinants, how to find determinants, minus j 2 plus 4, okay, plus k 6 plus 4. So you're going to get the components are minus 2, minus 6, and 10. And if you want to do vice versa, v cross u, it will be just the opposite, 2, 6, minus 10. And if I ask you, for example, what is the area of the parallelogram formed by these two vectors, it will be what? Square root 4 plus 36 plus 100. So it will be square root 140. So this square root 140 is nothing else the norm of that vector, and this is nothing else than the area formed by the area of the parallelogram formed by the vector v cross u. So anytime you want to find the vector norm of u cross v, the answer of u cross v, so you do this formula, you're going to get a vector, and this vector is nothing else than the vector perpendicular to the plane formed by the two vectors u and v. More application problems. Find the area formed by the two vectors u and v here, and you use then the area, find the area of the triangle formed by u and v. Since I want the area of triangle formed by the two vectors u and v, so first of all I need to find its cross product, because the cross product will give me what? The area. So I do, suppose this is the vector perpendicular to u cross v, so I do it here. So I'm going to get at the end 4 to 1, 5 if you do the determinant of u cross v. Now what I want to find the area of the triangle. So to find the area of triangle, I will do the square root, the absolute value of this answer, square root 16 plus 125, it will be root 42. Root 42 alone is the area of parallelogram. If I want to find the area of triangle, I divide it by 2. Another application problem here, they want the area of triangle formed by PQR. Same story, I do PQ, components of PQ. Anytime they ask about area of parallelogram and area of a triangle, you can from now and on do this property. This is PQPR. I'm going to find the components. You know how to find the components of these. So you do PQ cross PR. You're going to get a vector. This vector is perpendicular to the plane formed by these two. And if I want to find the area of triangle, so what do? I do absolute value, the norm of that vector, as you can see here, and I divide it by 2. More problems. Here I want to find the unit vector. The unit vector perpendicular, here I forgot to put perpendicular to the plane formed by the 3 points. These are the points This is the point P, this is the point Q, and this is the point R. Since I want norm of that vector perpendicular to that plane, so I do P cross product of PQ, vector PQ, and PR. If I do PQ cross PR, after finding the components of PQ and PR, I'm going to get a vector here whose components is 606. What I want the unit vector of that vector. So to do its unit, this is the unit vector. You can see this is small arrow. So I do n, which is this one, over its norm. Its norm is square root 36 plus 0 plus square root 36. So it will be 6 root 2. If you divide each one by 6 root 2, I'm going to get the norm. The norm to the plane formed by the 3 points P, Q, and R. So from now and on, any vector you want to find it perpendicular to a plane or perpendicular to three points in that plane, so you do U cross V or V cross U. So let us continue now. Suppose, what is a box product? The box product is a product of 3 vectors, but the first one, it's a cross, then I have what? Dot. You know, the cross product of 2 vectors is a vector. If you have U cross V, you're going to get this U cross V times a vector. Now it's a scalar product. Here, suppose you have a vector U prime. U prime scalar W is not a vector, it's a number. So here we have a number. So if I want to do geometric interpretation of that one, you know, the scalar product, if this is 1 unit, it's norm of the first one times norm of the second times cosine of angle in between, because here I took this one as 1 unit and here I have dot. And if I do some the cosine of the angle here, you can read it by yourself. What you're going to get at the end? I'm going to get, if I have a box product like this one, U cross V, then scalar with W, I'm going to get the volume of this parallelepiped formed by the 3 vectors U, V, W. So what is a scalar product or a box product of 3 vectors? It is nothing else determinants of the 3 vectors, and the answer is what? Of its volume. Volume of what? Of the shape formed by the 3 vectors U, V, and W. So let us take an application problem here. Suppose I want to find the volume of the box determined by vector U, V, W. You can write U cross V dot W. You can write V cross U dot W. You can write W cross U dot V. You can write W cross V dot W. Whatever, any combination you want, you're going to get the same answer. But what concerns us, if they're asking about the volume determined by 3 vectors, which is a parallelepiped. So I do the determinant. I put this vector 1, 2, minus 1, minus 2, 0, 3, and 0, 7, minus 4. If you do the determinant, you're going to get an answer, and this answer is nothing else than the volume formed by the 3 vector. This is called it's called box product. Concerning if you start by U, V, W, whatever, it's all the same. Here I gave you some application problems. You can solve it by yourself. Okay, more application problems. Here are the answer key for these application problems. So if I want to summarize what I gave you, U cross V, as we said here, U cross V is a vector perpendicular to that vector. It's norm U times norm V times sine angle in between times its unit vector n. And if you want to find it, if you want to find this U cross V, is nothing else than doing the determinants of this vector. You're going to get another vector, and this vector will be the U cross V if you do the determinant. And if you do its norm, the norm of the answer here of that vector, like in this example, is nothing else than the area of the parallelogram formed by the vector U and V. Okay, and if you want to find the volume of the box product, if you have, for example, if you want to find the box product, for example, you have the first 2 vectors is the cross, then scalar with the 3rd vector, it will give you the volume of the parallelepiped formed by these 3 vectors. So as you can see, this is a simple lesson, and I gave you some problems. As I said, you can solve it by yourself, and you have the answer key. You can check your work, and see you tomorrow in school.